What's going on, guys? Welcome back to Gabriel Gaprod. This time we are going to see how to shoot the 2D laser in Unity. And we are going to use shader graph to create a very simple shader, and then we are going to see how to code the shooting part of the laser. And this is a procedurally generated laser, which is awesome because we don't need any textures at all. And this effect can also be used as a blockade or in other situations as well. And in case you are interested in getting access to this whole project, this is available on my Patreon page. I left a link in the description. Alright, so let's see how we can shoot this laser. So I'm using Unity 2020.1 with the universal render pipeline and with the 2D render, which is easy to set up in case you are interested. All you need is to go to the project settings and in graphics, click on the scriptable render pipeline so you can locate your URP asset, and then with right click go to rendering and create a 2D render, which you can then assign right here in your URP assets. And that's it, the 2D renderer is set up. And in case everything is dark, make sure to add a global light in your scene. With that being done, all you need now is go to the package manager and make sure that you have shader graph installed. And in my scene I have an empty with the laser script that we are going to create, and then I have the gun sprite and the firepoint, which is simply an empty game object. And this gun and the scenario are from the asset store. I left a link in the description in case you are interested. Alright, so let's start with the shader. Let's create a 2D shader in 2D render, more specifically a sprite lit graph, so it can interact with the 2D lights of your scene. You can double click to open it up, and the first thing we need is a color property, which we can set to HDR mode and with a white color and alpha at 100. Next we need the very important step, which is a texture 2D called main text, and it is very important to rename the reference to main text underscore so the sprite renderer can work properly with this custom shader. We can even turn off exposed, because we don't need to play with this in the inspector. Now the first thing we need, so since we are not going to use any texture, we need to start with a UV node, so we can use a split node to have access to the green channel, and if we connect this to a power node, we get this nice gradient. Let's do once again the same, and let's add these two power nodes together. But as you can see, nothing special happens. So first we need to invert the green channel with a y- node. Let's set both power nodes to 10. And as you can see, we get dark in the middle and white in the extremities. So once again, we can invert this with a y- node. And if we connect this to a power node, we have control over the thickness of the laser, which is pretty cool. So let's create a few properties, one for the laser edge smoothness, which we can set a default value of 10 and connect it right here to these two power nodes. And then we can create another vector one for the laser thickness, which we can set at around 30 as default value. Now our next step, we can go ahead and multiply these with the color property and then connect it to the color input of the sprite lit master. Right, so let's save the asset, let's go to our scene, and for this laser to work properly, we want to create an empty game object, which I'm going to rename to laser02, and I'm gonna push it right here in front of the gun. Inside this empty game object, with right click we want to go to effects and create a line renderer. This is going to be our laser. And right here we have the positions, which is set to 2. The first one is the beginning and the second is the end point. As you can see, if we increase in the X, we extend our line renderer. Now let's go ahead and create a material out of the shader that we just created and assign it to the line renderer. So as you can see, we have our options here, we can play with that. And by the way, I have a global volume with bloom, so it adds a nice touch. You can create one with right click down here in volume. Right, so this shader is very simple as it is, so let's make it look cooler. For example, we can start with a Voronoi node, a very useful node. that we can multiply with the power, this power node, and replace the connection to this multiply. Right, and this is very static as it is. We can create a time node, which we can then multiply with a vector 2 called laser speed. Just like this. And if we connect this to the offset input of a tiling and offset node, and then connect it to the UV input of the Voronoi, we get a scrolling texture. Right, and we can increase the speed in the spectrum -1, we can change the color, play with the intensity, something like this looks nice. It's really up to your taste, obviously. By the way, you can also increase the width of the line renderer right here, something like this. As you can see, the Voronoi needs to be smaller. So we can create a vector 1 for the laser scale with a default value of around 5 and connect it right here to the cell density of the Voronoi, right? And if you don't want to have too many transparent spots in your laser, what we can do is connect the Voronoi to a remap node. X is going to be 0, and the output X, if we increase it, we are going to clip the black values. 0.2 seems like a good value. Alright, so we have a nice simple looking laser shader. There's many things that you can do. I even recommend you to check out this laser shader that I made a while back. Links in description or in this video. Right, so once you have played with these values and with the color, we want to shoot this laser and we want this to follow our mouse and collide with the scene, right? So let's go ahead and create a script which I'm going to attach to my gun. I'm going to disable the previous script and attach it right here. So let's open it up, and the way we interact with this laser is very simple. First, we check if we have clicked on the fire button, which, by the way, if you go to your project settings to the input manager, you will notice that the fire 1 button is set to left control, to mouse 0, which is the left mouse button, and to the joystick button as well, which is useful, right? And this get button down will only be triggered when we click the fire button, and we want to enable the laser. Then we want to check if we are holding the fire button down, and we want to update the laser. And then we want to check if we stop clicking on the fire button. So we use get button up, and then we disable this laser. So as you can see, these are functions that we will create in a moment. And we also want to disable the laser right in the beginning, in the start function. Let's start the enable laser function. But first we need a few variables. The first one is going to be for the camera. The second one is going to be for the line renderer, which is our laser. And then we need a firepoint, a transform variable. So in the enable laser function, what we want to do is enable the line renderer. We want to set it to true, just like this. Then we got the void update laser function, which we will see in just a few moments. For the disable laser function, once we stop clicking the button, the fire button, we want to set the line renderer to false. Basically, we disable it, right? So let's save this and let's go to our scene and assign a few variables. I'm going to assign the camera and then the line renderer. The fire point, we will assign it in a moment. So as you can see, once we press the left mouse button, we enable the laser. If we hold the fire button down, it keeps on firing, and once we stop clicking, it stops the laser. Great. But now we want this to follow our mouse position. We basically want to control the second position of our line renderer, and that is done in the update laser. First, we are going to set the position. So we are going to set the position of our line renderer. The first position, which is 0, we want to set it to the fire point position. For the second vector, the second position, which is the index 1, we want to set it to the mouse position. And what is this mouse position? For the mouse position, we need to convert our mouse position on the screen to a world point. So we are going to use a function that exists in every camera, which is screen to world point. And we want to feed it the input.mousePosition. But make sure it is a vector2. We are going to cast a vector2. So let's save this, and in Inspector now we can assign our firepoint, which once again it is an empty game object right in front of the gun. And once we test this, you will notice that our laser is acting really weird. And that's mostly because we are not using world space. We need to turn on use world space in our line render. And as you can see now, it will snap to the world start position, which is 0, 0, 0, at least in our scene. But once we press play and once we test this, the first position goes to the fire point, and the second position, or the second vector, goes to our mouse position. Awesome, looking great. But our gun is not rotating. The way we make our gun rotate to the mouse position is by creating a rotate to mouse function. And first we need a direction between the mouse position to the position of the object that holds this script, basically transform.position. So now we have the direction between our gun and our mouse position. What we then need is to create an angle, a float. And we are going to use a mathematical function which will give us an angle in radians between direction.y and direction.x. And then we need to convert the radians to degrees, so we can fit it to the Euler angles that goes from 0 to 360. So we are going to multiply this with mathf.radians to degrees. With this angle now we can rotate the object that holds this script towards a rotation. And this rotation is going to be a private variable, a quaternion, called rotation, where we are going to say that the Euler angles are going to be equal to a new vector where we don't want to rotate in the x nor in the y, but in the z axis. And now in the update function we can call the rotate to mouse function, so it keeps on rotating the gun towards the mouse. Alright, looking really nice. We have our gun rotated to the mouse as well as the laser following the mouse position. Now we only need to make sure that the laser is colliding with the colliders of our scene. As you can see, I have a polygon collider in my scene, right here. And for the laser to collide with these, we first need a direction once again between the mouse and the position of the object that holds this script. If you want, you can create a global variable for the direction. And we are going to create a raycast it2d. This variable is going to be equal to physics2d.raycast. And this little function needs first the origin position and then the direction, which is going to be the direction.normalized. It's basically a vector that goes from 0 to 1 with the correct direction towards our mouse. And we want to limit these raycasts with the length of the vector that goes between the mouse and the gun position. So basically we use magnitude, which returns the length of this vector. Now we check if the raycast it2d has hit something. If it hits a collider, we want to set the second position of our line render to the hit point. And once we save this and we test it, as you can see, as soon as it collides with the polygon collider, it will stay right there and it will not go any further. And that's only because we are saying that it shouldn't go further than the mouse position. And once it detects the collider, it snaps to the hit point. Great! Looking really nice. We only need a few more things to make it better, like some particles. So let's see how we can use particles with this laser. So first we need to create two empty game objects, one for the start visual effects and another for the end visual effects, the ones that are going to be at the end of our laser. Let's push it right here. So for the start visual effects, let's add a particle system for a few particles. Let's also create a new material. And let's change the shader so it is universal random pipeline particle and unlit, not lit. I'm going to change it in a moment. We want to set the surface type to transparent and the blending mode to additive. And let's also set the color mode to additive, and then for the base map, let's search for particle, and we can use the default particle that comes with Unity. Then we can assign this to our particle system, and let's, for example, use a cone which is already set, rotate it 90 degrees in the Y, set the radius to around 0.2 and increase the angle to something like 35. We can also increase the rate over time to around 20 and set the start lifetime to be between 0.3 and 0.6, and we also want to randomize the start speed between 5 and 10. Let's also set the start size to be random between 0.1 and around 0.2, 0.3. Obviously this is a personal preference, you can play with these values as you wish. In the size of a lifetime we can use this curve right here, so it shrinks at the end of their lifetime. Great, now let's duplicate this particle system for a beam flash, where the start lifetime is going to be 0.2 and 0.3, something along those values. It's not going to move, so the start speed is 0, and the start size can be something between 0.5 and 1.5. We can decrease the rate over time to around 10. And let's select both particle systems and choose a blue color. And in my case it's not changing because my shader is set to particles lit, and like I said, we want to use particles unlit. Right, once we change that, we get these really nice blue particles. Now let's duplicate the particles in the beam and drag them to the end VFX and make sure that the position is 0, 0, 0. So the particles, we are going to rotate in the opposite direction, which is minus 90 degrees. And we are going to increase the angle, something like this. We also want them to move faster and leave less. If you want to stretch these particles, you can go to the render mode and set it to stretched billboard and increase just a tiny bit the speed scale to around 0.01. Right, looking cool, looking nice. This is a good example, so we can proceed to the next step. So let's go back to our script. And we need two public game objects, one for the start VFX and the other one for the end VFX. And in the start function, we want to call fill lists, which is a function that is going to fill a list of particle systems, called particles, a private list. So let's declare down here this function. We want to iterate this, and we want to iterate through all of the children that are in the start VFX game object. We want to cast the particle system, and we want to check if the particle system is not null. If it isn't null, then we want to add this particle system to the particles list, just like this. And we want to do the same for the end VFX particle system. We just need to replace this right here and down here as well. Don't forget to replace this. Right, so, and we are doing this because now we have the possibility to, when we enable the laser, we can iterate through all the particles and say play. We can copy this and paste this to the disable laser, and instead of play, we want to stop all the particles, right? And I just noticed that first we need to call fill lists in the start function before the disable laser. And we also need to initialize our particles list, just like this. So once we save this and we go to our scene, you will notice that every time we press the fire button, we enable the laser, and once we stop it, the particles also stop. Now we only need two things and we are almost done, which is setting the start VFX to the firepoint and the end visual effects to the end point of the laser. We can do it down here in the update laser. We can say that the start VFX.transform.position is going to be equal to the firepoint.position. Let's not forget to always cast this to a vector 2 because we are in 2D and we don't want this to go in the Z axis. For the end visual effects, you can do something very simple, which is setting the position to be equal to the line renderer, the second position, basically the index 1. Once we save this and we go back to our inspector and we press play, our laser is working properly. It's looking really great, and I really enjoyed the end result. I hope you have enjoyed this result too. You can obviously then do a bunch of stuff like I did. I created a few variations, as you can see. And if you want to have a closer look, I left a link in the description to my Patreon page, and you can get access to all of these variations that I created and much more shaders and visual effects that you can use in your game. But that's basically it, guys. I hope you have enjoyed this video. I want to say a big thank you to all my patrons. Without you, these videos would be impossible to do. And a special shout out goes to the super mega patrons, to the top tier patrons, which are Adam Bradley, Angel R. Dev, Dodolo, Eric C, Goblin Plague, Hero Syndrome the Game, Himara SPC, John Nix, Josh McCormick, Remediola, Ken Lee, Luo Chang Chen, Marco Rossi, PS, Regan Nadu, Stephen Melton, TK, Victor Nathan, Zor, Zyger, and Ilya Zimov. You guys are awesome, you guys rock. So thank you for watching, guys. I hope you have enjoyed, and see you in the next video.